Hi there. I thought I would shoot a little video of the how the SharpSky project is progressed. I've now got the printed circuit board back from manufacture in China. So there's a double layer board, uh, which is 3-hole plated. Yeah, it's done a really good job. I'm really pleased with it. So that's the blank board. It's about 95mm by 45mm or thereabouts. So yeah, that's a blank board, and that's a fully populated board. So briefly just explain what all the components are. I'm sure most people probably can guess, but I'll go through it anyway. So as I say, there's a blank board and a populated board. That's the PIC microprocessor running the firmware. That's a microchip 18F2550 processor. For those that maybe aren't familiar with PIC microprocessors, I can thoroughly recommend going onto the microchip website and checking out the datasheet. You'd be amazed what's in these PICs. It doesn't look like much, but there's a heck of a lot packed into it. I won't even start going through it all because there's tons. It's easy just to look at the website. That's the motor driver, which is a Darlington, basically just an array of Darlington drivers. The PIC drives the motor via that driver chip. 9-pin D-type connector for the motor and also the temperature probe. So the temperature probe can, which I'll show you in a minute, the temperature probe can be connected in the motor housing, or there's a socket here for the temperature probe as well. So you can either connect the temperature probe here or via the D-type. Standard power connector, 2.1mm 5mm power jack. It's the socket for the manual focus control, which I'll show you in a minute, and then the standard USB connector. It's the underside. Then we've got power supply section up here, really simple 780L05 based power supply with a reverse polarity protection diode, crystal oscillator circuit here for the PIC to give it some sort of clock. To minimise the amount of discretes on the board, I've used these resistor packs. So we've got an isolated pack for the LEDs, current limiting for the LEDs, and then a common mode pack for pull-ups on the board. So it just minimises the number of components that need fitting. There are a few discrete resistors, but most of them are in these resistor packs. So it shouldn't take, I mean, I timed it. It took me 20-25 minutes to build it, not going at any particular pace. So oh yeah, these we've got some connectors at the end here. One, I've got a breakout connector for the motor. Should somebody want to use a different connector or want to bring the motor out, you can bring it out on these pins here. And then these pins here are for the LEDs. So we've got 2 direction LEDs, one for the USB status and then one for the manual control. Right, so that's the assembled board. Okay, this is the motor housing, which is built from a really sturdy, I mean it's a very strong 50mm by 50mm by 50mm potting box, similar to the one I used on the prototyping board. I've changed the connector. Obviously now we've got a D-type. It's now a 12-volt motor rather than the original 5-volt motor that I used on the prototype board, although quite a lot of people made the modifications to use a 12-volt motor. And then we've got the temperature probe, which is basically just push fit and then epoxied into position, and that's wired to the D-type. So the temperature probe is mounted in a stainless cap, and it's waterproof. I've submerged them and they're definitely waterproof. so there shouldn't be any problem. And there's a back cover which I'm currently waiting for. They're on back order at the moment, but hopefully I should get a rear. There'll be a rear cover at some point in the next week or so, hopefully. Here's the case with holes. I haven't mounted the LEDs yet. I'm going to do that tonight. I thought it was less confusing to look at the case without the LEDs. So basically the board mounts on these lugs here. So it's really simple. It just fits in a bit like that. So a small amount of adjustment. There you go. And then all the connectors, and there'll be. I'm going to mount the LEDs on the side of this part of the case, so I don't have any wires trailing to the lid. So when all the LEDs are mounted and wired in, I can just drop the lid on, screw it in, and that's finished. Then it's done. Okay, this is the manual control, which is very similar to the manual control used on the prototyping board. Excuse me. That just plugs in like so. Also, as part of the kit of bits, rather than people messing around trying to build or make a cable to go from here to here, which is usually can be quite prone to error, I've sourced some pre-made cables which are 9-way female to 9-way male. They're nice cables. They're really well made. That just saves all the hassle of having to build a cable. You literally just build the board, plug this end into here, plug this end into here, and you're done. It's a straight through cable. I'll show it working later. I just thought I'd give a quick demo of the actual the working parts. So yeah, thanks for watching. Any questions, and yeah, just email me. Cheers.